3 years ago, 11 universities and their vocational college partners were handed an industry standard challenge: design a battery pack, build it, validate it, and integrate it into a Ram ProMaster EV. This was the Battery Workforce Challenge.
Through the outstanding partnership with the US Department of Energy and Argonne National Laboratory, we are able to give students a hands-on experience outside of the classroom, where they can problem solve and work in a team environment, all critical skills for success in the industry.
It's what my engineers are doing every day. So these students are learning and training and developing their skills just like they were working for our company.
Year 1, defining the architecture. Utilizing industry-standard modeling and CAD tools, students began designing their battery packs while studying the fundamentals of lithium-ion technology.
A battery is very complex. There's so many different components when it comes to the mechanical, the thermal, the electrical, and they all have to play in harmony.
This is giving our members an actual chance to see the engineering process.
We're learning some industry-level skills and software tools like NX, AVL, Gamma Technologies, which we never would have had the opportunity to as an undergraduate.
We are designing what our battery packs are going to look like, setting ourselves up so that next year we can hit the ground running, get our battery packs built and tested.
Year 2, subassembly of components. Teams focused on building out their module, battery disconnect unit, and thermal system designs. Along the way, they faced critical industry challenges: sourcing, design validation, pivoting under pressure, and sequencing their builds for manufacturability.
The lessons we learned came down to what you have in design or in theory is different from what you have in real life. Everything can look good on a computer screen and in a presentation, but when you actually go down to building it, there's all kinds of real-world discrepancies and errors.
The distance between any high-voltage components has to be very specific to prevent any risk of shorting. So we're looking at the distances from our model on the computer to physically how did that actually come out.
We had to do practically an entire module redesign, but we did our best to maintain the functional requirements and KPIs that we started with while incorporating the design changes that were necessary for the competition.
Project management focuses a lot on empowerment within leadership. We're going to give them the tools that assist in communication for very technical statuses, and then they're going to have these skills to custom tailor them to the needs of their team and their project.
Year 3, build, validate, and integrate. Kicking off with an intensive safety boot camp, students suited up in high-voltage PPE for hands-on vehicle training. Teams that rose to the challenge moved into the build phase, navigating expert inspections, leak testing, and end-of-line performance checks.
We're going to be doing like a sanity check first to make sure we are operating safely, and then we're going to proceed with DC fast charging, drive cycle testing, and HPPC for characterization.
On the software side, they're working on structured verification validation. They test the individual subsystems and then they test it as a system, hardware in the loop. And then now, after integrating their software with the hardware that they've built, they go into the pack level and they try to test it with the vehicle.
What we're seeing is applied application of the battery pack being able to be integrated, having everything connected and talking to the computers, having the vehicle communicate to the battery pack, and then turn numbers into action by making the vehicle move. The organizers from Argonne National Lab have done a tremendous job getting everything aligned and everything working. Programs don't exist without these kinds of people, and they really bring that extra level to how they turn out.
Argonne National Laboratories' collaboration with Stellantis is huge. These kids wouldn't have this opportunity if it weren't for them. So they're actually bringing a whole new group of kids to the workforce. You know, the opportunities are endless.
The Battery Workforce Challenge was fueled by world-class sponsors, providing the advanced software, hardware, and expert mentorship students needed to succeed. Thanks to their support, more than 1,000 participants gained the real-world skills to charge the industry forward.
Workforce development challenges like these are so important to Stellantis. I am proud that more than a dozen challenge students have joined the Stellantis team to launch their professional careers. The skill and dedication shown by the participants will be a great benefit to our industry in the years ahead.